Hey everybody, today we're going to start our third day of angle relationships. And this is by far my favorite part of this because it involves algebra, which you know I love. So basically what we're going to be doing is we're going to be writing and solving algebraic equations based on relationships that we see between angles in a diagram. So we're basically looking at three scenarios for angle relationships. The first thing that we can see is that angles are congruent to each other. If we see a diagram where the angles are congruent to one another, then in the equation that we write, we're going to set the two expressions equal to each other. And I'll show you what that means in a little bit. If we look at a diagram and we see that the angles are complementary, then we're going to add the angles together and set that sum equal to 90 degrees. If we see that the angles are supplementary, we're going to add the two angles together and set the sum equal to 180. The last bullet says, read what the question is asking for carefully. It may not always be just to solve for x. And we'll get to that on the second page, but for now, for questions 1 through 4, we're just writing an equation to solve for x. So in looking at this first picture, number 1, we see that angle x and the angle that measures 2x together form a right angle, which means that together they add to 90 degrees. And another word for that is they're complementary. So when we write our equation here, we're going to add this angle plus this angle and set that equal to 90 degrees. Okay, we're going to combine our like terms. So 1x plus 2x is 3x. We're going to divide both sides by 3. And we're going to get x equals 30. Now that's all we were asked for in this problem. We were only asked to solve for x. However, if you wanted to check this to see if you did the problem correctly, watch how easy it is. So x is 30 degrees, we know that. If I plug in 30 for x here into the expression 2x, this angle here winds up being 60 degrees, and I know that I did the problem correctly because 30 plus 60 gives me the 90 degrees. Okay, let's take a look at the second picture. We have this angle here that has the 2x minus 30, and we have this angle here that has x. Remember, whenever we can draw this rainbow, semicircle, however you want to look at it, we know that those two angles make a straight angle or 180 degrees. In other words, they are supplementary. So this time, we're going to add them together, just like we did before, but this time the sum is going to be equal to 180. Now, a couple things to mention. If I want to put parentheses around that expression for that angle, I can. When I put the parentheses there, we know they don't really mean anything because there's really a 1 in front of that set of parentheses. And so essentially they don't mean anything. It's just a nice way to separate the two angles. Again, they're optional. I'm going to combine like terms. So 2x plus that 1x. And I'm going to solve this two-step equation. And that's going to give me 3x equals 210. And I'm going to divide by 3. And I'm going to get my solution, x equals 70. Now, that's as far as I needed to go in this problem. But like I said, if I wanted to check this, if this angle is 70, this angle here had better be 110. Otherwise, we did the problem wrong because 110 plus 70 is 180. So if I wanted to just do like a quick check here, I can just type into my calculator 2 times 70 minus 30, and it does work out to be 110. Okay, let's take a look at number 3. We have intersecting lines, and we have, remember, those 4 angles that are formed. We're looking at the relationship between this angle here that has the 4x minus 20 and this angle here that has the 2x plus 30. Hopefully you can see that these angles are opposite each other. Some people like to do this, color this in. It looks like a little bow tie. But these opposite angles, angles that are not touching each other, are what we call vertical. And vertical angles are always congruent. So here's how we're going to write this equation. We know that this angle equals this angle. So the equation is going to look a little bit different. It's going to look like this. 4x minus 20 equals 2x plus 30. Now, it's been a while since we've solved equations with variables on both sides. So just to kind of go over a few things, you cannot combine like terms here because there are no like terms on this side and there are no like terms on this side. You can't combine across an equal sign. So what you're going to have to do is you're going to have to eliminate either the 2x or the 4x. Now this is a positive 2x. So the only way to cancel out a positive 2x is to subtract 2x. And if I do it on that side, I'm going to do it on this side. I could have also subtracted 4x from both sides, but I generally eliminate the term with a smaller coefficient, so I'm not dealing with negatives. So positive 2x and negative 2x cancel. 4x minus 2x is 2x minus 20. And we have a nice two-step equation, which is what we want. So I'm going to add 20 to both sides. And I'm going to get 2x equals 50 and divide by 2, and x equals 25. You can say 25 degrees. If you leave the degree symbol out, it's really not a big deal. Okay, now again, that's all they asked me for in this problem, but if I wanted to check, if I typed into my calculator 4 times 25 minus 20, this angle would be 80 degrees. And if I did the same thing here, 2 times 25 plus 30, that angle here would also be 80 degrees. And so I know I did the problem correctly. Okay, the last picture we have parallel lines intersected by a transversal. And we're given this angle here, and we're given this angle here. And there's only 2 possible relationships that can exist here. The angles are either equal or they're supplementary. There's no other way, there's no other relationship. Now, hopefully you can see that this angle is clearly acute. Sorry about the handwriting. And this angle is clearly obtuse. And we know that any acute angle is supplementary to any obtuse angle. So we know the equation here is going to be 6x plus 15, again, optional parentheses, plus 3x plus 21 equals 180. And you can flip them. You could have said 3x plus 21 plus 6x plus 15. It doesn't really matter. But combine like terms, 9x plus 36 equals 180. So subtract 36. 9x equals 144. Divide by 9. X equals 16. Now again, that's all they asked us for in this problem. But if you wanted to check this, if you do 3 times 16, sorry about the handwriting, plus 21, and you figure out what this angle is, it comes out to be 69 degrees. And if you do 6 times 16 plus 15, if you plug it into that angle there, you're going to get, I believe, 111. And we know that checks because 69 plus 111 is 180. And we said that they were supplementary. Okay, on to the second page. So for 5 through 9, now we're going to actually find the missing angle measures. So for number 5, they're asking us to find DBC. DBC is this angle, DBC is this angle right in here, the one that has the 7x minus 9. Before we find DBC, before we ever find an angle measure, we always have to find x. We always have to write an equation and solve for the variable. Now, if you look at the relationship here between these two angles, you see this 90-degree angle, which means they're complementary. They add to 90. So my equation is just going to be 7x minus 9 plus 4x equals 90. Combine like terms. Okay. Add 9. And then divide by 11. So hopefully you came up with x equals 9. Now again, I'm asked for DBC. So that's 9 is not the final answer. Now I'm going to plug in that 9 for x. So 7 times 9 minus 9. And that gives me 63 minus 9. And so my final answer to this question is 54. Again, if I want to check this, this angle here has to be 36 because together they have to add to 90. So if I substitute in the 9, look what happens. I get my 36. I know I did the problem correctly because the two angles add to 90 degrees. Okay, so hopefully you're getting the hang of this. Let's look at the next one, find the measure of STU. So again, STU is this angle there. But in order to find STU, we have to find the value of the variable first. We have to find Q. So look at the relationship between these two angles. I'm making that semicircle, that rainbow. We know that those two angles are supplementary, which means they add to 180. So here's my equation, 3Q plus 15Q plus 18 equals 180. Combine like terms, 18Q plus 18 equals 180. Subtract 18. 18Q equals 162. And Q comes out to be 9. Okay. Now, again, we're not done here. We need to figure out STU. So all we have to do is plug in that that 9 for Q. And so our final answer to this problem is 27 degrees. Again, this angle here had better be 153. Otherwise, we did the problem wrong. And if you do 15 times 9 plus 18 on the calculator, it does check. It does come out to be 153. So we know that we did the problem correctly. Okay, let's take a look at number 7. We're looking for the measure of angle CEB. Okay, so CEB is this angle here. In order to find that angle, we need to find x, and so we need to use the other given angle in the diagram, which is this angle here that has the 2x plus 11. Hopefully you can see, here's that little bow tie again, or maybe you just see that the angles are opposite each other. They're vertical angles, they're equal. So the equation is just going to be 5x minus 19 equals 2x plus 11. again, I have to move variables to one side. So I'm going to subtract 2x from both sides. That's going to give me 3x minus 19 equals 11. I'm going to add 19 to both sides. 3x equals 30. Divide by 3. X is 10. Okay? Now I'm going to find CEB by plugging in that 10 for x. So 5 times 10 minus 19 gives me 50 minus 19, which is 31 degrees. So my final answer is 31. Now, if this angle is 31, plug in 10 here, and you'll see that this angle is also 31. The last part of this, they're asking me for the measure of CEA. CEA is this angle here. Now, hopefully you remember that angles that are next to each other or adjacent to each other in this picture are supplementary. So all we have to do is 180 minus 31, and that will give us the final answer. CEA is 149 degrees. And that also means that this angle is 149. Okay, remember those four angles add to 360. Okay, let's look at number 8, south W, then determine the measure of ABC. So hopefully you could see this diagram here. This angle is clearly obtuse, and so is this angle. So if they're both obtuse, that means they're equal to each other. They're also corresponding, which is another way to figure out that they're equal to each other. But I think the easiest here is really just to see that they're both obtuse. So that means they're equal. So my equation is going to be 4W plus 40 equals W plus 115. Move variables to one side. So I'm going to subtract 1W from both sides. That's going to give me 3W plus 40 equals 115. Okay, and now I'm going to subtract 40 from both sides. Sorry about the pen. So 3W equals 75. Divide by 3. And I'm going to get W equals 25. Okay. Now that's not the end of the question. They asked me for ABC. So I'm going to go ahead and take that 25 and plug it in for W. So I'm going to do 4 times 25 plus 40 is 100 plus 40, which is 140 degrees. Again, sorry about this pen. So the final answer to this question is 140 degrees. If I wanted to check this, if I plug in 25 here, 25 plus 115 is also 140. Okay, last problem. I'm asked to find the measure of EGH. So EGH is this angle here. I have no information about that angle. So I have to work with the information that I'm given. I have to work with the 4x minus 30 and with the 2x plus 20. I have to work with this angle and this angle. So hopefully, let's look at the relationship between those two angles that have the expressions. Hopefully you can see they're both acute. They're also alternate exterior angles. If you draw that Z that we've been talking about, or that I've been talking about, you'll see that if I start here and go here and go here and go here, neither of the angles fall on that Z. and we know that angles that are not on the z are all equal to each other. So no matter how you get to this equation, we know that the two angles are equal to each other. So our equation is going to be 4x minus 30 equals 2x plus 20. So again, variables on both sides. We're going to subtract 2x from both sides. And that's going to give us 2x minus 30 equals 20. And we're going to add 30 to both sides. And we're going to get 2x equals 50. My pen is really unhappy right now. I'm going to divide by 2, and I'm going to get x equals 25. Okay? So I'm not quite there yet. Now I need this angle here, EGH, okay? But before I get that angle, I need to get this angle first, okay? Because I don't have any information about that angle yet. So I'm going to take my 25 and I'm going to plug it into this expression here. So I'm going to do 4 times 25 minus 30, which is going to give me 100 minus 30. And so this angle here is 70 degrees. This angle here, if you check it, is also 70 degrees. And last thing that you need to know here is that angles that are next to each other in this diagram are supplementary. Or we also know that any acute angle is supplementary to any obtuse angle in this picture. Those are the only two relationships in this diagram. The angles are either equal or they're supplementary. So one last step is to do 180 minus 70. So the final answer to this question, the angle that we're looking for, is 110 degrees. Okay, so I didn't give you anything else for today because I knew these notes were going to take a while. So please, please make sure that you go back and that you have these notes copied correctly. Again, I apologize about the pen. So if there's anything you didn't understand, please let me know. But make sure you have all these notes filled in. We're going to spend another day on this tomorrow. So have a good rest of your day. Bye. Bye.